In this video, we will know about functions, especially about how to distinguish between a function and a relation. So recognizing functions. So what are functions? Functions are like formulas in which we give some input, like the value of x is an input that is given to a function which is a formula, and we get a particular output. That is a function. So to understand better about functions, let me give a very quick read. What are functions? Many things in real world consist of relationship between two things. The number of hours a person works, the amount of money earned, the number of gallons of gas bought, and the distance a person can drive. The names of students in a class and their heights are few examples of relationship between two things. The names of students in a class paired with their height is an example of a relation. These two things can be paired, such as name comma height or height comma name. The name and height are written as ordered pair, which simply means that one comes first and the other comes second. When a relationship is expressed as an ordered pair, it is called a relation. When a relationship is expressed as an ordered pair, it is called a relationship. A set of ordered pairs is a relationship. If a relationship between the names of students and their heights is written as name comma height in parenthesis with name as first thing in the ordered pair, then names are the set of all starting points. This set of starting points is called domain of the relation, and the heights are second thing in the ordered pair, and the set of all, which are the set of all ending points. This set of ending points will be called as a range of a relationship. So a relation will have a domain set and a range set. Domain set will consist of all the first things in an ordered pair, and a range will be the set of all things which comes in the second part of the ordered pair. If a variable x represents names of students, and the variable y represents heights of students, then the ordered pair name comma height can be written as x comma y, just like a coordinate in Cartesian plane. This set of values of x will be the domain, and the set of values of y will be the range. So that is a quick read about a relation. Here we go. Let's understand the meaning of a function and a relation. Look at the following set of ordered pairs. So we have 1, 4, 2, 6, 2, 8, 3, 10, 4, 12. Let me draw this in form of a domain set and a range set. A domain set and a range set. So all the first things in the ordered pair are the elements of domain set. So we have 1, 2, 3, 4. 1, 2, 3, 4 constitute the domain set. And 4, 6, 8, 10, 12. 4, 6, 8, 10, and 12 form the set of range. They are the elements of range set. Now let's see how things are mapped. 1 is mapped to 4. So 1 is the input, and the mapping is done through a formula. That means in that function, if we substitute x is equal to 1, we get an output. That output is the range set. So then the second ordered pair is 2, 6. So 2 is mapped to 6. Then 2 is mapped to 8. 2 is mapped to 8 also. Then 3 is mapped to 10. 3 is mapped to 10. And 4 is mapped to 12. So here this is the mapping. Now let's understand further. The values are written as ordered pair x, y such that domain set includes 1, 2, 3, 4. range set includes 4, 6, 8, 10, 12. Notice that X value has 2 as, notice that the X value of 2 is paired with 2 different values of Y. A relation can have a member in the domain paired with more than one from the range. So the one that we just saw is an example of a relation. What is a relation? In a relation, the domain set elements can be paired with more than one element in the range set. Going forward, to the next example, look at this set of ordered pairs. So we have 1, 2, 3, 4, 5 as elements of domain set. So I'm getting ready with the domain set elements. Domain set elements are 1, 2, 3, 4, and 5. And the second number, that is 3, 5, 7, 9, and 11 form the elements of range set. So range set elements are 3, 5, 7, 9, and 11. Now let's understand the mapping between these two. 1, 3. So 1 is mapped to 3. 2, 5. 2 is mapped to 5. 3, 7. 3 is mapped to 7. 4, 9. 4 is mapped to 9. Finally, 5 is mapped to 11. So here clearly we see that for a distinct input, for a particular input, there is a distinct output. No two elements of range set has a pre-image in domain. Means every one element of the domain set is mapped to a single element in the range set. Now, the values are written in the ordered pair x, y such that domain set includes 1, 2, 3, 4, 5, range set includes 3, 5, 7, 9, 11. Notice that each x value is paired with only one y value. A relation is such that each member of the domain is paired with one and only one member of the range set is called a function. So here distinctly, which is a relation and which is a function. A function is a relation. A function is a relation in which each value of each x is paired with a value of y. That means each member of the domain set is paired with one and only one element in the range set. So such kind of mappings, such kind of relation is called a function. So how to distinguish between a function and relation? All relations are functions, but all functions need not be a relation. So a function is a relation in which for every x in the domain set, there is one and only one element in the range set. But in case of a relation, an element of a domain set can be mapped to 2 or more elements in the range set. That is how we distinguish between a function and a relation. Let's understand it better through this example. Determine if the following represents a function or a relation. To understand this, let's write the ordered pair. Ordered pair. So, in the domain set -3, -3 is paired to 4. -2 is paired to -8. -1 is paired to 0. 0 is paired to 8. Finally, 1 is paired to -4. So clearly you can see that elements in the domain set, that is the X part of the ordered pair, they are distinctly mapped to one and only one element in the range set. So -3 is related to 4 only. -2 is mapped to -8 only. -1 to 0, 0 to 8, 1 to 4, 1 to -4. So when every element of the domain set is mapped to one and only one element of the range set, such a relation is called a function. So here, this set of or this ordered pair represents a function. Let's consider this example. Do the following ordered pairs represent a relation or a function? For that, let's have the domain set and the range set. The first number in the ordered pair are elements of the domain set. So that's 0, 1, 2, 3. 0, 1, 2, 3. These are the elements of domain set. And 5, 6, 7, 8, 9, and 10 are the elements of range set. 5, 6, 7, 8, 9, and 10 are the elements of the range set. Now let's see the mapping. 0 is mapped to 5. 1 is mapped to 6. 2 is mapped to 7. All well until now. If the set of elements are up to this, then we can say that this relation is exclusively a function, because for every one value or one element in the domain set, there is one and only one element in the range set. But now let's see 1, 8. So 1 is mapped to 6 as well as 8. 3 is mapped to 9 and 2 is mapped to 10. So here you see there are two elements in the domain set. Two elements in the domain set, which is 1 and 2, which are mapped to two different elements in the range set. And whenever this happens, such kind of a relation is not a function. It's just a relation. So this is not a function. So it is a relation. It is a relation. Okay, let's do a conclusion of our understanding. A relation is any set of ordered pairs. A relation is any set of ordered pairs x, y. A function is a special type of relation where each input, means the domain element, is paired with exactly one output. That is a range element. So all functions all relations are a function, but all functions need not be a relation. Now, you can check with these example questions. Check the ordered pairs from 1 to 10. Find out whether they are functions or relations as your personal practice. I hope this video is useful. Next topic will be the function families.